Imagine for a second that you're standing in a wine shop. You've decided to treat yourself, so you pick up a bottle from Piedmont, Italy.
And it's probably not cheap.
Right, definitely not cheap. You take it home, you pop the cork, and you pour a glass, you hold it up to the light, and you just sort of pause.
Because it's pale.
Exactly. I mean, really pale. It's translucent. It has this very delicate, light ruby color, maybe even fading a bit to orange at the rim.
It looks fragile, like something you drink on a patio in July without thinking twice.
Yeah, it looks like it's going to be light and fruity, maybe like a Pinot Noir or Gamay. So you take a sip expecting something soft, something easy, and wow.
The trap snaps shut.
It grips your palate with the force of a freight train. It dries your mouth out instantly. It's aggressive, powerful, just structurally intense. It feels like you just chewed on a tea bag wrapped in sandpaper.
It is the ultimate sensory bait and switch. You've just met Nebbiolo.
And that contradiction is exactly where we're going today. We are doing a deep dive into the chemistry of the Nebbiolo grape,
Which is arguably the most paradoxical grape in the wine world.
We've got a great stack of source material here. Everything from genomic sequencing of the grape varieties to historical records from the 19th century Piedmont courts. Plus some pretty dense technical breakdowns of anthocyanin profiles.
Right. The real molecular biology stuff.
Exactly. And our mission today is to distill all of this and figure out how a wine that looks so weak can be so incredibly strong.
Because we aren't just talking about tasting notes here. We're looking at a literal molecular tug-of-war happening right there in the glass.
Because the sources suggest this paradox isn't just an accident of winemaking, it's actually genetic.
It is. The Nebbiolo grape is essentially programmed to deceive the eye. You have a situation where the color pigments are biologically engineered to fail, or at least to fade rapidly, while the structural compounds, the tannins, are built to outlast almost anything else in the cellar.
So it's basically a biological practical joke.
In a way, yeah. But it's a joke that takes, 40 years to tell properly.
Okay, before we get into the molecules, let's set the scene briefly. We're talking about Piedmont, Italy, specifically the Langhe Hills.
Right, the home of the big names.
Barolo and Barbaresco. And the name of the grape itself gives you the first clue. Nebbiolo comes from the Italian word nebbia, meaning fog.
Which makes sense.
I always assumed that was just because it's foggy in Piedmont in the fall. I mean, I've seen the pictures. The vineyards look like they're literally floating in clouds.
That is the most common theory, and it holds up. The harvest is remarkably late, usually late October, which is exactly when the mists roll through those valleys.
But the ampelographic records in our sources mention another theory.
Oh, about the bloom on the grape.
Yeah, the theory that the name refers to the grape itself. The berries are covered in this heavy, foggy bloom, a natural wax called pruina. It makes the purple grapes look almost gray or misty right there on the vine.
So it's mysterious before you even pick it.
Mm.
But let's get into the hard science. You mentioned earlier that the color is programmed to fail.
Which sounds a bit dramatic for a wine people call the king of wines.
It sounds dramatic, but chemically, it is entirely accurate. To understand this, we really have to look at anthocyanins.
Okay, define that for us quickly.
Anthocyanins are the molecules responsible for the red, purple, and blue pigments in plants. They're what make a blueberry blue and a red wine red. Now, in the world of wine, not all anthocyanins are created equal.
Right.
If you look at a grape like Cabernet Sauvignon or Syrah wines that are famously dark and inky, their dominant pigment is a molecule called malvidin.
Malvidin. Okay, I'm picturing like a bodybuilder.
That's actually a great analogy. Malvidin is the bodybuilder of pigments. It's stable. It resists oxidation. It keeps wine looking deep, dark purple for years. It can handle rough treatment.
But Nebbiolo is different.
Very. If we look at the source material on the Nebbiolo genome, we see something completely different. Nebbiolo is classified as and this is a quote, peonidin 3-O-glucoside prevalent cultivar.
Wow, that is a mouthful. But I'm guessing peonidin is the key word there.
It is. It means the ratios are flipped. In Nebbiolo, the highly unstable pigment, peonidin, dominates. The data shows peonidin makes up anywhere from 35 to 61% of the profile.
That's a huge chunk.
It is. Meanwhile, malvidin, that stable bodybuilder pigment, is deficient. It's only found at levels of about 13 to 32%.
So if Cabernet is built out of bricks, Nebbiolo is built out of, what, straw?
Maybe dry leaves. Peonidin and the other dissubstituted anthocyanins found in Nebbiolo are highly susceptible to oxidation. As soon as the juice is exposed to air during fermentation and aging, those pigments just start to fall apart.
They change state almost immediately.
Exactly.
Which perfectly explains why when you see a young Nebbiolo, it might be ruby red at first, but if you look closely, or if it's just a few years old, it's already turning garnet or brick orange.
Right. In most wines, that orange brick color is a sign of old age. It means the wine is past its prime. In Nebbiolo, it's just Tuesday.
It's just doing what it's genetically programmed to do.
It happens rapidly because the primary coloring agents are chemically unstable.
It is wild to think that the king of wines is genetically deficient in the one thing consumers usually associate with quality and power, which is dark, inky color. I mean, we're trained to think dark equals strong, right? If I pour a glass of watered-down looking red, I assume it's going to be light.
And that is the core of the deception. Because while the genes for color are coding for instability, the genes for structure are doing the exact opposite. This brings us to the iron fist part of the metaphor.
The tannins.
The tannins, specifically proanthocyanidins. Nebbiolo has some of the highest levels of these compounds in the entire wine world. And here's the disconnect. Usually you get massive tannin from thick skins.
Right, think about Cabernet again. Thick skin, lots of color, lots of tannin. It makes perfect sense.
But Nebbiolo is translucent, so you'd assume it has thin skins.
It does have thin skins, and usually thin skins mean lighter, lower tannin wines.
But Nebbiolo skins, and importantly the seeds, are absolutely packed with these powerful structural compounds. It punches way above its weight class.
Yeah. So you have a grape that physically cannot hold its color, but it can absolutely bury you in tannin.
Correct. And this is where the terroir influence becomes critical. We mentioned the harvest is late October. That is an incredibly long growing season. It's actually one of the first vines to undergo bud burst in April and the last to be picked.
Why does it need so much time? If the skins are thin, wouldn't they rot or dry out if you leave them on the vine that long?
It needs the time to tame the monster. Because the tannin levels are so high, specifically in the seeds, you have a real problem. If you picked Nebbiolo in September, like you picked Merlot, those tannins would be green.
Green meaning bitter?
Bitter,
Right.
vegetal, extremely harsh, like biting into an unripe banana peel.
Yeah.
You need that long hang time in those specific calcareous mineral soils of the Langhe to let the seeds ripen fully.
You need the chemistry to shift.
Right, you need the tannins to mature chemically
Right.
from bitter to just massive.
So the goal isn't to get rid of the tannin, it's just to change its personality.
Precisely. You want them ripe, not green.
Okay, so we have this paradox clearly established, weak color, massive structure. But here's my issue with the chemistry. If I buy a bottle of really good Barolo, which is 100% Nebbiolo when I drink it, it's not just painful astringency.
Well, if it's 20 years old, it shouldn't be.
Right, if it's too young, maybe it is. But a mature one is smooth, it's elegant. How does the chemistry actually resolve this conflict?
This connects to the much bigger picture of aging. Nebbiolo is a wine that demands time because of a process called polymerization.
Polymerization. That sounds like we're making plastics in a lab.
It's the same basic concept making chains,
Yeah.
but here it's delicious chemistry. Think of a tannin molecule in a young wine as a short chain. It's small, it's jagged, and it reacts very readily with the proteins in your saliva.
And that's the dryness.
Yes. The tannin literally binds to the lubricating proteins in your mouth and precipitates them. It strips them away.
So friction increases.
Exactly. That's why it feels dry or grippy. It's literally removing your saliva.
Charming. So we're paying good money to have our mouth lubrication chemically stripped away.
We are. But over time, and we are talking 15, 20, sometimes 40 years, these tannin molecules and the anthocyanins start to bind together. They form longer and longer chains.
I see.
Imagine those jagged little rocks turning into long, smooth river stones. As these molecular chains get longer, they become too large to interact with your saliva in that same aggressive way.
So the iron fist relaxes.
It becomes the velvet glove. The texture shifts from astringent to incredibly silky. And here is where it gets really interesting. This exact same reaction helps stabilize the color.
Wait, I thought the color was inherently unstable. I thought the peonidin was falling apart.
It is, initially.
Uh-huh.
But when the anthocyanins bind with the tannins during this long aging process, a process called copigmentation and polymerization, they lock into a new state.
Oh, wow.
They won't ever be purple again, but they lock into that classic translucent garnet hue with the orange rim. The color becomes permanent, in a way, through the same process that softens the taste.
That is fascinating. The very thing that makes it harsh, the tannin's what eventually saves the color.
Exactly. They literally need each other. Without the massive tannin, the color would just turn brown and drop out completely. And without the color pigments, the tannin would just remain harsh. They stabilize one another.
And the sensory result is totally unique because the fruit profile changes too, doesn't it?
Completely. You start with fresh cherry and raspberry and rose petals in its youth, but as those chemical chains lengthen and oxidize slowly, you get tertiary notes: tar, leather, truffles, dried flowers.
Tar and roses, that's the classic descriptor for Nebbiolo.
It is. It's a mix of the floral and the industrial. It sounds unappealing to someone who hasn't tasted it. I mean, who wants to drink tar? But in the glass, it's hypnotic.
So we have this wine that is chemically destined to be pale and tannic, requiring decades of patience. But looking at the history books in our source stack, it seems like for a very long time, nobody actually knew this.
This raises one of the absolute best questions in wine history. What was Barolo before we understood its chemistry? And the answer is pretty surprising. Until the mid-19th century, this massive, dry, tannic wine was actually sweet.
Sweet, like a dessert wine? Or like a fizzy soda?
A bit of both, honestly. We have to remember the climate in Piedmont in the 1800s. It gets cold fast in the foothills of the Alps. The harvest is late, remember?
Late October.
Right, so by November and December, the cellars were absolutely freezing.
And yeast needs warmth to work.
Correct. The cold would kill off the yeast or put it to sleep before it could eat all the sugar in the juice. So you are left with a wine that had high residual sugar, and that sugar masked the tannins. It completely covered up the monster structure.
It's like putting a huge spoonful of sugar in very strong, bitter coffee.
Exactly. It made it palatable. It was likely fizzy, sweet, and relatively light to drink.
So when did the mask come off? When did we get the dry monster we know today?
Around the 1850s, it was a perfect storm of people who wanted better wine. You had the Marchioness of Barolo, Giulia Colbert-Folletti.
Yeah.
You had Count Cavour, who was a key political figure in Italian unification, and they brought in technical help.
The sources mention a French ethologist, Louis Oudart, and an Italian, Paolo Francesco Stagliano.
There's actually a lot of debate among historians over who deserves the most credit there. For a long time, Oudart got all the glory, but recent research suggests Stagliano, who was Cavour's winemaker, did the heavy lifting.
Just to keep things balanced, our sources report both theories, but the outcome was the same, right?
Right. The key is that they brought modern, mostly French techniques to Piedmont. Better hygiene, better yeast management, and perhaps most importantly, they learned how to keep the fermentation going until the wine was totally dry.
They basically figured out how to keep the yeast awake.
Yes, they used heated rooms and better vessel management. And once the sugar was gone,
The iron fist was revealed.
completely,
Right.
without the sugar to hide behind, those massive proanthocyanidins we talked about were suddenly front and center.
It must have been quite a shock. You go from drinking a sweet, fizzy red to something that dries your mouth out completely.
It changed the identity of the region overnight.
Yeah.
Suddenly, this was a wine that required aging. You couldn't just drink it, you had to lay it down. It became an aristocratic wine simply because only the wealthy could afford to sit on inventory for 10 or 20 years.
But that brings us to a much more modern conflict. Because not everyone wanted to wait 20 years, we have to talk about the Barolo Wars.
Oh, yes.
It sounds like a movie title, but it was a very real conflict in the 1980s and 90s.
It was a literal civil war in the wine world.
Yeah.
Ideological, financial, generational.
Set the stage for us. What was happening?
Fast forward to the 1980s. The global wine market is booming. People are drinking Napa Cabernet, Bordeaux, wines that are dark, fruity, dense, and relatively smooth upon release.
And Barolo is none of those things.
No. The traditional way of making Barolo involved leaving the juice on the skins for a long time, 30, 40, even 50 days, to extract absolutely everything, then aging it in massive old Slavonian oak casks called body.
And the sources say some of these were not exactly clean?
That's the polite way to put it. Some were outright dirty. The wines could be oxidized, volatile, or just painfully tannic for decades. If you opened a bottle before its 20th birthday, it might be undrinkable.
It's a tough sell.
Exactly. So a new generation of winemakers looked at this and said, we are broke. We are losing the market. Nobody wants to wait 20 years for a wine that might be spoiled. We need to modernize.
Enter the modernists. What did they change?
They brought in technology, rotary fermenters, which look a bit like cement mixers. They spin the juice to extract flavor quickly, in just a few days, without pulling out too much of that harsh seed tannin.
So trying to cheat the extraction process, get the flavor, leave the bite.
Exactly. And crucially, they introduced the small French oak barrel, the barrique.
Mm.
225 liters.
Now, this is important for the chemistry. New oak gives you vanilla, toast, spice, but it also does something to the color, doesn't it?
It does. And this is the crux of the war. Small barrels allow